Hello, dear students. Today we are starting with Electronics Minor course. Welcome you all to Electronics Minor course. Let me share to you syllabus of university. So here you can observe the syllabus on the screen. You have opted electronics as a minor, and for electronics minor we have the course of embedded system with AVR microcontroller. It consists of 4 chapters in all, which encompasses chapter number 1, Introduction to the Embedded System and Microcontroller. Chapter number 2, Fundamentals of AVR and its programming in C. So, in chapter number 1, we are going to study the basic points of the embedded system as well as microcontroller. In chapter number 2, we will be studying AVR, microcontroller, and basics of the programming of AVR microcontroller. In chapter number 3, we will be studying the programming AVR microcontroller using embedded C. So here we are going to study the programs. Chapter number 4 consists of the case studies. So here we are going to study the applications, certain applications, interfacing applications of the AVR microcontroller. So this is our whole syllabus. So today I will be discussing with you the details of the chapter number 1. The chapter number 1 is Introduction to the Embedded System and Microcontroller. So it consists of mainly 2 parts. In the first part, we'll be studying Introduction to the Embedded System. As already we have discussed, embedded system consists of hardware plus software. Okay. So now here what you can observe is we are going to study introduction of the embedded system in the first part. So what is embedded system? What are its characteristics? What are its elements, applications? How to design embedded system? What are the different metrics which are used to design the embedded system? And as it is a combination of hardware and software, we will need some development tools. So these software development tools will be introduced here, which will include editor, assembler, linker, compiler, IDIC, programmer, simulator. So this we are going to use during our practical course. The second main part of this chapter is microcontroller architecture. So here we are discussing the historical part of the microcontroller, and then we'll be going to its classification application. All of you know that the CPU of the computer consists of microprocessor, and microprocessor is the brain of your computer. So this microcontroller that we are going to study is similar to this microprocessor, but it is different from microprocessor also. So in what way it is different from the microprocessor? So this comparison we are going to discuss in this difference between microcontroller and microprocessor. So it is important to choose a proper microcontroller, and therefore we'll be discussing the criteria for choosing the microcontrollers. There are 2 computer architectures which are popularly used. One is Harvard and another is von Neumann. So we'll be studying basics of Harvard and von Neumann architecture along with 2 more architecture concepts, RISC and CISC. RISC meaning reduced instruction set computer architecture, and CISC meaning complex instruction set computer architecture. Our microcontroller is with RISC architecture, but we are going to compare this with the CISC architecture. So comparison of RISC-CISC architecture will be discussed along with some concept of parallel processing. All of you have heard the word parallel processing. Parallel processing is used to improve the performance of the computer. And to improve the performance of the computer, many of the things will be done in parallel by the computer. and different tactics are used for this. One of the tactics is pipelining. So we will have a short introduction of the pipelining in this chapter. Now I think you are clear about the chapter 1, which will be introduction to the embedded system as well as introduction to the microcontroller. Now let me share with you my presentation. Today we'll starting with the embedded system, chapter 1, introduction to the embedded system. On the screen, you can observe number of pictures. They show the number of gadgets in your day-to-day life. It may be the CRO which you are using in the electronics laboratory, the car, the robot, the router, the television, the aeroplane, the camera, the card puncher, the CT scan, and the most popular mobile. So all these gadgets you know. And these gadgets or these machines, they have embedded system within it in order to provide automation to it. Okay, so embedded system is covering the every area of the life today. Now, if we extend one application, car, you can observe here number of things. There are number of places where the embedded systems are installed for different purposes. Now here you can observe in car, we have night vision and lane warning. So here embedded system is installed. Similarly, you can observe tire pressure monitoring. So this is monitored automatically with the help of embedded system. You can observe there is audio system, there is voice recognition system within car, which is again an embedded system. There is a GPS, which is embedded system. DVD player, which is also embedded system. Even you have a parking or reverse assistant to your car. This is nothing but a embedded system. Automatic lock is an embedded system. Automatic speed control is an embedded system. Airbag is also embedded system. So in one car, you may have a number of embedded systems installed. So from this, you can have an idea how the embedded system has been spread in our day-to-day life. Here also you can observe some more applications of the embedded system in the car. Now, let us see this graph. What it shows? It shows the automotive embedded system market size from 2023 to 2034. Now, if you go from 2023 to the current year, which is 2025, you can observe there is increase of 4 billion US dollars in embedded system market. Now, if you study the market prediction up to 2034, then market of the embedded system will be increased almost up to 60 billion US dollars. So such a big increase in the market of the embedded system. So you will come to know how relevant is to study the embedded system. Now let us go to understand what is meant by an embedded system. You can observe one figure here which consists of two boxes, a software box within a hardware box. So this software within hardware constitutes embedded system. So embedded system has hardware plus software. Here certain input variables are monitored by embedded system. They are controlled by embedded system. They are processed by embedded system and provided as the output variable with help of user interface, hardware, software, and link to some other system. So apart from your embedded system hardware and software, you have input variable, you have output variable, you have user interface and link to the other systems. Now, let us see what is the definition of the embedded system. An embedded system is a small computer that is built inside another machine or a device to do a specific job. Now, if you observe car as a machine here, then a small computer is installed into the car for automatically controlling the braking system, automatically controlling the airbag system. So, the small computer for inflation of the airbag when accident occurs. So this is the specific job of the small computer which is present inside the airbag system, which is present in the car. This airbag system consists of a small computer within it, and its job is to inflate the airbag when impact occurs. Are you getting the point? मुलांनो, एम्बेडेड सिस्टीम म्हणजे छोटासा कम्प्युटर असतो जो एखाद्या मशीन मध्ये किंवा डिव्हाइस मध्ये एखाद्या ठराविक काम करण्यासाठी तो बसवलेला असतो. आता ह्या कारचं जर एक्झाम्पल घ्यायचं झालं तर कारमध्ये जसं म्हटलंय की नंबर ऑफ एम्बेडेड सिस्टीम आतमध्ये बसवलेले असतात, तुम्हाला माहितीये. तर एक एक्झाम्पल घेऊ आपण एअरबॅग सिस्टीमचं. एअरबॅग सिस्टीम मध्ये एक छोटासा कम्प्युटर बसवलेला आहे आणि ज्यावेळेस ऍक्सिडेंट होतो तेव्हा कारला इम्पॅक्ट बसतो आणि कारला इम्पॅक्ट बसल्याबरोबर तुमच्या एम्बेडेड सिस्टीमला इनपुट मिळतं आणि इनपुट मिळाल्याबरोबर एम्बेडेड सिस्टीम आउटपुट प्रोव्हाइड करते आणि ते आउटपुट काय करतं तर एअर बॅग जे आहेत त्या ते फुगवतं किंवा इन्फ्लेट करतं. म्हणजे ह्या एम्बेडेड सिस्टीमचा जॉब काय आहे तर ऍक्सिडेंट झाल्यावरती बलून्स आहेत, बॅग्स आहेत ते फुगवणे, जेणेकरून जो ड्रायव्हर बसलेला आहे त्याला काही इजा होणार नाही. तर आता कितीतरी प्रकारच्या एम्बेडेड सिस्टीम वेगवेगळ्या मशीन्स मध्ये आपल्याला पाहायला मिळतात. तर एम्बेडेड सिस्टीम म्हणजे काय असतं, एक छोटा कम्प्युटर जो मशीन मध्ये किंवा गॅजेट मध्ये बसवलेला आहे आणि जो एक ठराविक काम फक्त करत असतो. So this is what an embedded system is. Now let us go to examples of the embedded system. In your day-to-day life, you can observe these things. And all these things, they have one or more than one, mostly more than one embedded systems within it to perform the functions. What are the examples of the gadgets which have embedded system within it? The washing machine, the remote control of the TV, the microwave oven, car, mobile phone, television, printer, many more. These are the examples of the embedded system. Now, let us explore what does an embedded system have inside it. Let us find what an embedded system have inside it. As we have studied, mainly there are two parts of the embedded system. One is the hardware and another is the software. What do you mean by hardware? Hardware is nothing but that you can see with your eyes. That means the physical parts are the hardware of the embedded system. So which physical parts are there which are present in the embedded system? Number one, a microcontroller. Microcontroller is a small computer which is present on a chip. A memory. Memory is used to store the program and the data. The sensor. Sensor is nothing but a device which is capable of sensing environment around the embedded system. You can compare sensor with our sensory organs like ears, eyes, nose, tongue, and skin. They sense our surrounding and give information about that surrounding to us. In embedded system, the sensors are doing the same thing. They are sensing the input variable and converting that input variable to the electrical signal. So, last year, you have studied the sensor. Sensor is nothing but a device which essentially senses physical or chemical stimulus and converts it into an equivalent electrical signal. For an example, you can consider thermistor. You have heard of the thermistor, you have worked with the thermistor. Thermistor is nothing but the thermal resistor. It is a kind of resistor whose resistance changes in accordance with the temperature. So, it is used to sense the temperature. There are sensors which can sense the pressure. There are sensors which can sense the speed, light, etc. LDR also you have seen, light dependent resistor, which measures the light, amount of the light falling on it and converts it into equivalent electrical signal. So sensors are used to measure the input variables which are given to the embedded system. Now, let us come to the another component of the embedded system, which is nothing but the actuator. Now, actuator is also similar to sensor, but it does it in reverse way. Meaning is that we are providing electric signal to the actuator, and actuator is converting this electrical signal to some action. It may be the rotation of the motor or turning on and off of the switch. The actuator is used to perform output like turning on motor or display or switch on certain gadget. So motor is your actuator, relay is your actuator, solenoid is your actuator, even display is your, it may be your actuator. Display is not actually actuator, it is going to display the quantity. But motor, solenoid and relay, they are actuators. Now, apart from hardware, the embedded system has a software. Whatever you can't see with the eyes, but it is doing work. It is called as a software. Software is nothing but the commands given to the computer to work it in a to process information within it. So this software usually is written in C, C++, or even in Python. And this software is stored in a small chip within a embedded system. So in short, what you can see, embedded system have hardware and software within it. मुलांनो आपण शिकलेलो आहोत की एम्बेडेड सिस्टीम मध्ये हार्डवेअर असतं, सॉफ्टवेअर असतं. जे डोळ्याने दिसू शकतं ते हार्डवेअर आहे, जे डोळ्याला दिसत नाही ते सॉफ्टवेअर आहे. डोळ्याला दिसणारे पार्ट्स आहेत मायक्रो कंट्रोलर, मेमरी, सेन्सर्स आणि ऍक्च्युएटर्स. मायक्रो कंट्रोलर ही छोटी कम्प्युटर चिप असते. मेमरीमध्ये आपण प्रोग्राम आणि डेटा स्टोअर करत असतो. सेन्सर आपल्या भोवतालचं सराउंडिंग जे आहे ते सेन्स करण्यासाठी वापरलं जातं आणि ते सेन्स करून सेन्सर तो इलेक्ट्रिकल फॉर्मॅटमध्ये कन्वर्ट करत असतो. ऍक्च्युएटर इलेक्ट्रिकल सिग्नल हा मायक्रो कंट्रोलर कडून रिसीव्ह करतो किंवा कम्प्युटर कडून रिसीव्ह करतो आणि त्यानुसार तो एखादी ऍक्शन परफॉर्म करतो, जसं की मोटर चालू करणं किंवा डिस्प्ले चालू करणं किंवा रिले चालू करणं वगैरे. आता याच्यामध्ये सॉफ्टवेअर सुद्धा आहे. सॉफ्टवेअर मध्ये इन्स्ट्रक्शन्स असतात. इन्स्ट्रक्शन म्हणजे कम्प्युटरला दिलेल्या कमांड. कम्प्युटर काय करतो, जे हार्डवेअर आहे ते कशा पद्धतीने आपल्याला रन करायचं आहे त्या पद्धतीने तो सॉफ्टवेअर मध्ये ज्या कमांड्स दिलेल्या आहेत त्या पद्धतीने तो रन करत असतो हार्डवेअर. सॉफ्टवेअर हे सी, सीपीपी किंवा पायथन मध्ये लिहिलेलं असतं. तर हे झालं एम्बेडेड सिस्टीमच्या आतला भाग. सो नाऊ लेट अस गो टू why embedded systems are important, because the one of the most important thing is they make machines automatic. They are fast, small, they use less power, they are cheaper and they are reliable. एम्बेडेड सिस्टीम का वापरायच्या, तर कुठल्याही मशीनला ऑटोमेट करण्याचं काम या एम्बेडेड सिस्टीम करतात. त्या फास्ट असतात, छोट्या असतात आणि कमी पॉवर खातात. कमी पॉवर खाल्ल्यामुळे आपले जे गॅजेट्स आहेत, जे पोर्टेबल आहेत, छोट्या साईज मधले आहेत, ते बॅटरी ऑपरेटेड असतात आणि मग त्याची बॅटरी थोडा जास्त वेळ चालते पॉवर कमी खाल्ल्यामुळे. त्याची कॉस्ट पण कमी असते आणि विश्वासार्ह पण आहेत ते. त्यामुळे एम्बेडेड सिस्टीम हे महत्वाचे आहे. आता why should you learn it as a computer science student? तुम्हाला का शिकायचं? The first important thing is understand how computers control real world devices. कम्प्युटर प्रोग्रामिंग बेसिक आपण करतो, पण ऍक्च्युअली रिअल वर्ल्ड मधले डिव्हाइसेस कम्प्युटरच्या साहाय्याने कसे कंट्रोल केले जातात हे जर शिकायचं असेल तर आपण एम्बेडेड सिस्टीम शिकलं पाहिजे. रिअल टाइम सिस्टीम साठी सॉफ्टवेअर कसं लिहायचं हे सुद्धा आपण ह्या पेपरमध्ये शिकू शकतो. सो वी लर्न हाऊ टू राईट सॉफ्टवेअर फॉर रिअल टाइम सिस्टीम अँड वी आर able to work with hardware as well as software together. सॉफ्टवेअर आणि हार्डवेअर बरोबर एकत्रित काम आपण इथे करतोय. आणि कुठल्या डिव्हाइसेस साठी हे युजफुल आहे? घरगुती, इंडस्ट्री, हेल्थकेअर आणि भरपूर वेगळे वेगळे. मिलिटरी मधले सुद्धा, नॅव्हिगेशन मधले सुद्धा, या सगळ्या ठिकाणी एम्बेडेड सिस्टीम आहे. तर त्याचं सॉफ्टवेअर जर आपण बनवायला शिकलो तर आपल्याला खूप मोठ्या अपॉर्च्युनिटीज अवेलेबल आहेत. आता आपल्याला पुढे जाऊन पाहायचे, व्हॉट आर द जॉब अपॉर्च्युनिटीज आफ्टर लर्निंग एम्बेडेड सिस्टम. सो number of fields in which you can work if you become embedded system expert. Robotics, smart home devices, medical equipment, car software, and one of the important thing is that you can work in the field of Internet of Things. डेटा सायन्स पेक्षा सध्या मोठं जे फील्ड आपल्याला या जगामध्ये मिळत आहे ते म्हणजे इंटरनेट ऑफ थिंग्स. आणि त्या इंटरनेट ऑफ थिंग्स मध्ये जर आपल्याला काम करायचं असेल, जास्तीत जास्त अपॉर्च्युनिटीज अवेल करायचं असेल, अनएम्प्लॉयड राहायचं नसेल किंवा सेल्फ एम्प्लॉयड बनायचं असेल, तर आपल्याला इंटरनेट ऑफ थिंग्स शिकणं गरजेचं आहे आणि त्याकरता एम्बेडेड सिस्टीम शिकणं गरजेचं आहे, जेणेकरून तुम्हाला असंख्य संधी ज्या आहेत रोजगाराच्या त्या उपलब्ध होतील. ओके, सो in short, what we have learned today, an embedded system is a small computer inside a machine that does a special job. It has hardware and software. You see it in things like washing machine, cars, mobile phones, and more. Okay, we will stop here. Thank you for patient listening, and we will study next part in the next lecture. Till then, goodbye.